Okay, so let me just share my screen with you, and then this is what we're going to study. So last time we covered the 3G and the 3G flows. This time we're going to cover the 4G flows. Okay, so first the mobility management and then the session management. I'm going to keep switching between the traces because the traces will have the updated information and easier to understand. The scanning a document may be a little bit complicated to understand, or maybe it may not have all the information covered. Okay, so you have the main procedures are attached procedure, detached procedure, connection release procedure, service area request procedure, tracking area update procedure, handover procedure, and your security procedure. Okay, so let's have a look at the attached procedure. Here is the call flow of the attached procedure. The user sends an attached request to eNode B. It sends an attached request to new MME. New MME will get the information of old MME from DNS, then identification request response, identity request response, and then the security procedure where HSS is done. Okay. Then MM initiated dedicated bearer deactivation procedure. This is if you have a dedicated bearer activated. Otherwise, just an update location procedure. Insert subscription information, and then your update location acknowledgement is done by the HSS. Then you have a create session request because you know the attach and create session is combined in 4G. So a create session request is going to send with your PGW coordinates with your PCRF and OCS, and its response is going to be received. We're going to check this in detail how this works. Then you have your insert initial context request, the radio resource assignment, radio server assignment acknowledgement, your DT or attach complete, and then there is a modify bearer request, which is similar to update PDP contact request, where your SGW is going to get the eNode B IP address. Okay, so I think it's better that we switch to the trace. You will better understand that. This will be a little bit complicated to understand. Okay, so what I can do is that we can open up a 4G attached trace, and you can better understand this from here. Okay, so these are all the main messages. Let me just check. I think I have the option of saving. Do I have the option of saving it in text? Save all messages in. I think we used to have an option of text as well. So I think I'll be able to save it in text as well, and then I can share it with you. Okay. So for the attach. So we'll see it afterwards. Okay. So attach. So let's just see these messages one by one. Okay. So in attach request, what we get to see is what is this? This is a combined attach. Okay. This is a combined attach means that it is going to be sending your attach your request to your MSC as well as uh, SDSL as well as MME as well. Why this is a combined attach? As you know, that 4G does not have any connectivity with CS4 nodes. It is always the PS4 node. So obviously, it is responsibility of the PS4 node to inform the MSC of the updated location area information. So I think Mr. Abu Bakr was asking combined. So this is now going to be the attached, combined attached. Okay. So this, then you have your Guti. This attach is not IMSI based. This is on Guti based. Okay. So like type of identity is Guti. Guti has your group ID, your MME code, and your MTIMSI. So based on your group ID and MME code, you will be able to identify which is the uh, old MME that was handling. Okay, this is all UE network capability. I don't think that is required by us. Then this is a PDN connectivity. So PDN connectivity is combined inside your attach request. Okay, so request type, it is an initial request. Then you have your last tracking area ID. So this is your last tag that is visited. Okay. Then if we come down, we have your old LAC information because you need your tag information and you need your LAC information as well. Your old Guti type was native Guti, okay, and your TIMZ is provided here as well, okay. So the main information that we require in an attached request is your location information and either your Guti or your IMSI. So you have your Scooty provided here. You have your old location area information and your old tracking area information. Okay. So all these information which is based on which your communication is going to be done. Okay. So the next message that is going to be is your since you are sending a GUTI, so it's going to be your identity request. So MME is going to send and it is going to ask its IMEI. Okay, and this is the identity response. So your IMEI is going to be sent by your MSIDN. Okay. Next is your map service request. As you know, map service request communication is with your EIR. To check IMEI argument, you're providing your IMEI, you're providing your IMSI. Okay. And here the map service confirm is going to be equipment is going to be whitelisted. ESM information, I don't think this is okay. So since we do not see any APN information in the attached request, since it's a combined the your create PDP or a PDN connectivity is part of your attached. So if you can view this again, we do not see any APN information here. User is sending an attached request, and the reason for that is that it's a GUTI based attach. If it was an IMSI based attach, then obviously the MS would have sent the APN as well. But if you pass through this, you won't be saying any APN information as well. So since your create session is part of your attach, so your MME is sending to the UE to provide the APN information as well. Okay. So here you get your APN information as well. Authentication, in this case, authentication is not being done in this phrase, but I will just cover the authentication one as well, how the authentication communication is done. Okay, so we can just, so this is your authentication information request to HSS, AIR request, okay? Since it is diameter based communication, so here you're going to see a lot of AVPs of the diameter, which are the default AVPs. Okay, so you get to see your session ID, you will get to see your authentication application ID, you'll get to see the origin host. These are all configured when you're configuring the HSS link. This is just information that is required. So your origin RAM, your destination realm information. Okay, so all this, the main thing that we need to see is your IMSI information, then the requested EUTRAN authentication information. So number of authenticator vectors, it is just asking for one vector. Just send me one vector. And if you know in 4G, there are one vector consists of 4 keys. Okay. So it is just asking one set of keys against this. So this is the IMSI. So HSS is going to check this IMSI and the number of requested vector that is it is requesting for. Visitor PLMN ID, nomad. So most of these AVPs are something that is a requirement of your diameter protocol when you're communicating with diameter. So some of these are the pet information that you need to add in that. In map, it is a little bit easier. Okay. So this is the response of HSS. Again, the session ID, the authentication, the realm information. Okay. We can just skip that. Yes, you need to check the information. For example, if you need to check with which HSS you are communicating. So you need to check that, okay, I'm communicating with HSS Karachi or HSS ABC, whatever it is. Okay, so yes, so this information just is something that you get to see in that. Okay, so for 3G, there is 5 number. Yes. For 2G, there is a triplet, 3 set, 3 keys. For 3G, it's called quintet, 5 keys, and for 4G, it is for 4 keys. Why? Because in 4G, it's your ciphering key or your integrity key is combined into KASME. It is a key for authentication, something like ASME stands. I don't remember what ASME stands for. So it's a combination of that. So the 2 keys have been combined. So here you see the random number. Okay, here you see the expected response. Here you see the authentication, and here you see the KASME. So this 4 information is being sent by your HSS, similar to what HLR used to send. And then the main thing that in diameter, what we always look for is diameter success code. So it is a successful response. So diameter success code means if diameter, if your response is not successful, that's going to be a different code. And then you can look up the diameter sheet and interpret that what information is being, why this is being sent. Okay. So 2001 is diameter success. You guys can open up the diameter information, the diameter messages, the and what sort of response correspond to what. So there is response in the 2xxx, 3xx, 4x, 5x. So each and every one has its own interpretation. We can ask someone who is an expert in OCS to have a session on this. Maybe if someone is willing, so we can engage someone to give a better training session for OCS as well, and then we can all learn how it happens. But for the time being, it's successful. Okay. So now we come back to 4G attach. Okay. So you get your authentication set information is done, and then you have your update location request. Okay. So you send your update location request where you again it's diameter, so a lot of pet AVPs. In update location, the main thing that you need to check is that the IP address and the GT of the MME, which will be sent somewhere here. So IMEI information. This is the RAT information, which RAT you are using. Where did the IP information go? Maybe information is a little bit. It must be somewhere in the start because every vendor has a different. This is your MZ, and the IP information must be in one of these AVPs. Let me just recheck this, okay, and then we can come back to this. Just check it in. Okay, we can come back to this afterwards. I think maybe it's not captured here in this. So you get to update location request and a get to update location answer. I'm not sure why it's not being captured here. You will have the APN information as well. AVN and your like. Let's see its response. The response in response, you can set the service has been granted. Okay. And the next thing is your quality of service information. So your uplink bandwidth maximum requested, your downlink bandwidth that is maximum requested. Okay, your context identifier is going to be 1. So this is your APN. So I mean, in some of these, you need to check this specific AVP. So this is your APN profile information. This is going to be your quality of service information, if I'm not wrong. this AVP. This is your AVP data is your AMBR. Okay, the average maximum bit rate. Okay, so this is your AMBR information. This is going to be your APN profile information. Okay, your context identifier. It is going to have which APN. So all APNs are going to be included. PDP type is going to be IPv4, so it's an IPv4. This is the name of the APN. Like this is the APN that I have subscribed to, so it's Jazz APN. Then you have your EPS subscribe quality of service profile. So this is your quality of service profile for your EPS. Okay, so this is your ARP allocation of retention and this is your QCI information. So QCI for normal browsing you have QCI 9. So the QCI that is subscribed is QCI 9. This will be then used by the PCRF to assign your policies and all that information. So the priority level ARP priority is 1. Preemption capability and preemption vulnerability. This we will cover later on when we will discuss the quality of service because this is a little of advanced information. Okay, so main information is that. So again, you have your AMBR BPS, which is your uplink bandwidth, downlink bandwidth. So if you look up a diameter message, you have so much information. Some is the pet information and some is your information that is required by you. So the previous one was for my APN, the first APN. This all information is for my other APN. So I have two APNs profiled. One was the normal generic for internet, and this is my IMS. So I'm subscribed to IMS, so I have an APN information for IMS as well. So for IMS, my quality of service profile, and then this is my quality of service. So for IMS, if you check the QCI is 5. Okay. So my ARP level, I mean, the bearers created ARP information is going to be included here. Okay. And the maximum bandwidth requested, maximum bandwidth sent. So there's so much information that you can see here. The main thing that you're looking for is the APN and the quality of service that is being sent by the HSS, whether it is successful or not. And the main thing is your diameter success. So diameter success 2001 should need to be here. Yes, what's the exact AVP need to be checked for on the authentication? Walid, I'm not clearly sure of the exact IVP, the exact AVP number. Okay, this is something that I need to check. I will check this that what AVP uh, number that you need to check, and this will be better understood when if you transform it into a text file, then you can easily check the APN, okay? And you can just search the keyword APN, you can search the keyword quality of service and search the keyword result code. And when you transform it into Wireshark, then it is more easier to understand. The AVPs are more easier to understand. And yes, it is depending on the provisioning of SIM card. When your HLR provisioning is done based on your SIM card and what services you have subscribed to. So these two messages, the authentication, and the third one is your authentication with your MSISDN. So you're sending a random number, you're sending an authentication key. And MSISDN is then going to respond back with your expected response. So this is the expected. So these are the three authentication related messages which was not covered in this attached request. Okay. So coming back to it, your authentication is done, your update location is done, and the next thing is your create session request. So you are going to send a create session request. I think I have covered it in this as well. If it is location initial context, yes, it is not covered here. Okay, so it's better that we just understand or we just read these messages in the trace. Okay, so this is a GTPC message of, as I informed you, that there is a signaling GTPC and then there is a user plane, the GTPU message. Okay, so here the local signaling IP address and the peer signaling. So this is your MME IP address. This is your SGW IP address. Coming down, what we need to see is your MZ information, MSISD information, the IMEI information, the user location information is going to be here. So it's your tracking area ID as well as your ECGI, EUTRAN, this cell ID, ECI information. Okay. Then this is going to be your serving the MNC and the MMC information RAT. Which RAT is this? It is EUTRAN. Okay. Then this is what? This is the tunneling ID for control plane. Just like we check the tunneling ID for user plane and control plane there, here's the tunnel ID for control plane. So, and this is on watch interface on S11. S11 interface between your MME and SGW. So, if you create a tunnel, like if I again mention the tunneling information, I think the guys who have joined now, I'll give you a bit of idea how tunneling works. The tunneling, this is how tunneling works. So you have this and you have this. Okay, so we're going to create a tunnel. So consider it as like a pipe. Okay, this is a pipe. And this is your MME. This is your SGW. Okay, then this is again your MME and your SGW. Okay, so a separate tunnel for your control plane. This will be for control plane, and this will be for your data plane. So it will have its own ID. This will have its own ID, and then they're going to communicate based on the ID. And then there is a separate tunnel for user plane, for data plane. So separate ID for this, separate ID for this. Okay. So here it is informing you that there we have this. Okay, so it is giving you the IP address of the control plane for MME side, and then your the user plane and the control plane information GTPC with your PGW. So over your S5 interface, what IP address is going to be used? This is the IP address that is going to be used. Okay. Then you have our access point name. So access point information is contained here. Okay, this is IPDN address allocation. You will have an IP address over here if you have an HSS assigned IP address. For example, you operate for static IP address. So if you operate for static IP address, then you are going to see an IP address over here. But since there is no static IP address, so there is no IP address over here. So both UP and CP will be created when you do yes, yes, because you need to have a control plane. You need to have a session plane, control plane, and user plane information as well. Later on, the user plane is going to be separated. It's going to be E node B and SGW. But right now we have to create both. Okay. So I mean, if there is any APN restriction, then this is your AMBR for uplink, APN, AMBR for downlink. So what is the in kilobits per second? If there is a restriction of APN AMBR, that is going to be sent to your SGW. Okay, then your quality of service level information, the MBR and the GBR. Yes, it is going to be on that, but initially eNode B is not directly coordinating with SGW. eNode B will coordinate with SGW once MME inform SGW that you need to communicate with eNode B. Okay, so this is just a signaling procedure. Once we complete this, then there are going to be signaling communication between eNode B and MME, and user plane communication S1 is going to be between MME and SGW directly. Okay, so MBR and GBRs. Yes, static IP address is used from HSS. Then you need to have a static IP. For example, I have an application. I'm working in a company and I have an application, and my application allows only specific IP addresses to access to my application. So I will ask the company to assign me these specific IP addresses. Okay, I need these specific IP addresses, or the company is, I'm going to tell company that, okay, I need 10 static IP. So whatever is available with the company is going to tell me, okay, I'm giving you this 10 IP addresses for this 10 users. And then I can configure in my application that, okay, only accept requests from this 10 IP addresses. Okay. So this is something that this is a practical example. Like if there is a company, for example, let's say I'm working in a company, and I have some portals and some URLs of the company which are specifically for company use. So I do not want anyone else to access those. I just want some specific IP that are assigned to my users that is going to be accessing those. So I will assign static IPs to my users so that they can get this uh, information. Please, one question. QCI can be controlled only by PGW without E-Node site support for session. For example, modify QCI. This is an advanced level question, my friend. We will come to it when we discuss the quality service information. Right now, we're just covering the basics, the call flows and all that. When we discuss the detailed quality of service information, then we can come into this advanced answer discussion. Okay? Because if I start answering this, then I'll be explaining it to you, and then most of the guys are going to be just they won't be understanding what we're just we're talking of foreign language. Okay, so once we come to the advanced level courses, the advanced level slides, in that case, when everyone is at the same level, then we're going to discuss this advanced level, then how your quality of service information can be changed and whether it's done by PGW or B and all that. Okay. And then your time zone information, which is something, if I mean there is an option available for time zone configuration as well. Okay. So next is your create session response. Since this is the communication between your MME and SGW, so you won't be having the PGW level information. The PGW level traces we will cover afterwards. So here you won't see the communication between SGW and PGW, and then the communication with OCS, PCRF, and all that. What is the time zone? Time zone is like +5 GMT, +4 GMT. Okay, every country has its own time zone information. And why time zone information is required is that because you have your CDRs available and you have your roaming contracts available. So you need to clarify the which time zone you are using, so that when your CDRs need to be reconciled with the RP, and even internally you need to know that what is the exact time on which a service was used. And plus there is, not in Pakistan we used to have for some time, but abroad countries you modify, like you have daylight saving and all that. So you need to modify the time zone information as well. So in order to keep your CDRs available, you have to assign some time zone to it as well. Because your regulatory requirement and your roaming part requirement is that you need to keep your CDR for a specific number of times. So you need to, and your time zone keeps on changing because of your daylight saving. So you need to specify your CDR that, okay, this CDR time is according to which time zone. Okay, so this is the response from your SGW. SGW is going to give its own IP address. So this is this GTPCU, the GTPC, okay, IP address. This is your peer signaling IP address. This is the local address, and this is so local address is going to be your MME information. Your P information is going to be your SGW information. Okay, and then we come down. We are going to check that this is the tunneling ID information, and this is the IP address. So we check that. So this is the SGW GTPC interface IP address. So we checked in the previous message, we checked that the IP address and the tunneling ID IP address of MME, and now this is the IP address of the SGW over the GTPC interface. This is the PGW IP. So this is the SGW IP, and this is the PGW IP address. For example, to directly communicate with PGW, you communicate with this IP address. If you want to communicate with SGW, you use this IP address. PDP address allocation. So this is the IP address that is assigned to this MSILGN against the APN subscribed. Okay, this is your quality of service information, your AMBR uplink, AMBR downlink, then your bearer ID Bearer ID is going to be 5. This is your first bearer that will be created, so it starts from 5. Then you have your user plane IP addresses. So initially we'll discuss the control plane. This is the user plane IP address. So this is the SGW IP address when you're communicating for user plane. This IP address will be passed on to the eNode B that, okay, if you need to have user plane information, directly coordinate with SGW. So SGW is giving its own user plane IP address. And it is also giving the PGW user plane IP address as well. But your communication of eNode B is going to be with SGW. So this is over S1U interface. And this is S5 interface. So SGW communicate with PGW over S5, S8. So this communication is going to be between these two IP addresses. This is the quality of, again, the MBR and the GBR information. And this is, I mean, this is what was in the previous message. We said that what was requested. This is what GGSN supports. But since it is not a dedicated bearer, so you're going to see that there is no information here. And the QCI is going to be QCI 9. Which 4 IPs, Yasir? Look, one IP, because you have a separate control plane, you have a separate user plane IPs. Okay, first understand this. Then there are two nodes that in UGW here. One is SGW, one is PGW. So SGW and PGW are going to have their control plane IPs, and then SGW and PGW are going to have their own user plane IPs. So 4 IP addresses. One is SGW control plane, one is SGW user plane, one is SGW user plane, PGW control plane, and one is PGW user plane. Okay. Yes, default QCI is 9. If you check into the QCI levels, the default QCI for IMS is 5, and for normal browsing, it's 9. Okay. So once you have that response, you're going to send an attach accept message. Yes, IP addresses is something that what is requested. If it's a static IP, then you specify that it's a static IP. And like I mentioned in your create session request, you would have seen an IP address, and that would have been static IP address. Otherwise, IP addresses are dynamic IP address. If there is a static IP pool, we specify that it is while configuring that APN and that IP pool, we specify that it is a static IP pool. Other than that, it is all are going to be dynamic. Okay. So you are going to send an attach accept message. Attach accept message. You're going to send the activate default EPS bearer context request. This is response to it. This is the APN that was assigned that you had requested. This is the IP address that is assigned to the MSSDN. Okay, this is the negotiated quality of service. Okay, we said negotiated and is being assigned. This is the APN AMBR information for a specific APN. This is the AMBR information that is going to be sent. Then this is your updated GUTI information. Okay, like just we used to send in attach accept. We used to send a PTMZ. Now we're sending the GUTI. Okay, just to give you a view, where do we stand? We stand over here. Okay, attach accept. So this is going to be sent to the user equipment. Okay, attach accept. So this is where we're standing. Okay, coming down a little bit, the location area information. This is the final location information lag. Okay, the identity is GUTI, obviously. It is not MZ. No, 4 addresses are not assigned to user. Who said 4 addresses assigned? Only one IP address is assigned to user. Where did you see 4 IP addresses? Only one IP address. This is that. This is the code. This is not 4 IP addresses. This is basically how the internally it is mentioned. UI address 1, like it's like this. Don't get confused with this. It's like this. 10.43.227.174. So it is separating these dots with assigning that, okay, the first the information before is 1. Okay, then this is the second part, this is the third part, this is the fourth part. Okay. So it's not four different IP addresses, it's just single IP addresses, and like Omar Rati mentioned, four octets part of it. Okay. So APN AMBR, you get your GUT information, you get your LAC information, and you get, and this is something the network features which are supported. So you send an attach accept message. It's better that I close this and then we see. Okay. So the next message is your SGS location update. Okay. Since I did not enable voice over LTE, I separated it. I separated small flow. So here it's assumed it is what is being sent by the attach request. I mean, if you're going to see the attach request, you're going to mention which voice service am I going to use. If I'm able to track that information, then you can see that, okay, I'm specifying that which voice service here. Voice domain preferred for EU TRAN is IMS PS preferred, CS voice as secondary. Okay. But since I did not enable my voice over LTE, so it is then going to perform a combined location update with your SGS location. So in your SGS location update, which is between your MME and your no. We are not covering the IMS flow now. This is information that is being provided to the MSC. Okay, this information is MME to MSC. Since MSC does not have a direct link with the UE in 4G eNode only connects with MME. So in order to update your information, you have to send an SGS location update request. So this is your SGS location update. Okay, and here you're just going to send the location area information. Okay, so here you're sending the location area information, lag, the new lag. This is the old lag, this is the new lag. So you're informing MSC that this is the IMSI and this is the MME that is serving this IMSI. And this is an IMSI attached and this is the location area information. So that when there is a paging, MSC knows which MME to correspond to. Yes, this is for CS fallback. Yes. Combined is, yes. In 4G, it is always combined attached because MSC does not have any link with eNode B. So if you don't have IMS enabled, you will opt for CS fallback. So SGS location update is for CS fallback. And then you see the SGS location update accept message. Okay, so this have been accepted. And here it is giving the IMSI as well. So this is the temporary mobile subscriber identity. Like we have a PTIMSI in PS core, in CS core, it is IMSI information, the temporary mobile subscriber identity. So this is something that is being sent by MSC, which will then be sent to the MME. So this is the initial context request. Initial context request is being sent where you are going to send your MME UE S1 application part ID. And here you are seeing the eNode B user equipment S1 API ID. So you have an S1 application part. So the S1 API ID at MME end is going to be this, and at eNode B end is going to be this. Then you're informing that what is the aggregate maximum bit to the quality of service information which is being supported. You are telling the eNode B that, okay, which is the QCI that is being used. Then you're telling the GTP tunneling ID. This is the tunneling ID that is going to be used between your eNode B and MME. Then this is a security key, the encryption and the integrity and the encryption algorithm that is going to be used between MME and the eNode B. And then there is a security key which is being sent. Okay. And SRVCC information is also being sent that, okay, this is possible. SRVCC is basically when a user moves from 4G, you are on a call and you move from the coverage of 4G to 2G and 3G, so your call needs to be continued. Okay, so SRVCC procedure, we're going to check its call flow when we cover the voice over LTE. information. Okay, so this communication is between your MME and your E node B to establish basically a bearer, establish the signaling information between MME and E node B, and then E node B, based on this, E node B is going to establish a session with the user equipment. And this is the response from the E node B. I mean, you can consider this like you have RAB assignment request and RAB assignment response. So now this is the response of your E node B. Here it is going the S1. It is acknowledging the MME side S1 application part ID and the E node B application part ID. Then it is giving its own GTP tunneling ID, and it is also giving the transport layer IP address. Okay, so this is the IP address of the E node B. E node B is informing, and in the previous message, what you're going to see is, I mean, if you transform it from binary into decimal, you're going to see that there is a transport layer address here as well, and this transport layer address. So this transport layer address is the address of your STW. Okay, so your MME in your initial context setter request is going to inform E node B that okay, when you're performing any user plane communication, this is the transport layer address on which you need to communicate. And I believe it starts from here. This is the first part, this is the second part, this is the third part, and this is the fourth part. So it is 10 dot something dot something dot something, and this is the SGW user plane IP address, which was received in your create session response. Okay, so this is your SGW user plane IP address, and this is your E node B user plane IP address, which E node B is giving this one. This is the user plane address of the E node B, which E node B is giving to your MME. And then MME is going to perform an update request where it is going to share the E node B IP address with SGW. Okay, and the GTP tunneling ID as well. So setup request, setup response, and then you have your attach complete. And attach complete, you will get your activate default bearer context has been accepted. Okay, so by the user. And so this attach complete is the response of your attach accept. Okay. Then your mobility management information, this message is sent specifically to, I think this is to get your, I don't think this is, yeah, this is communicating your universal time in a local time zone. This is, I mean, an internal message which is not required. Next is your modify bearer request. Since you need to establish a user plane, the S1U between your E node B and your SGW. So there is no communication between E node B. So here MME is going to tell SGW that what IP address of the E node B for user plane you're going to use. Okay, so this local and peer IP address, this is just for communication, the communication of this trace message. This is not the actual information. The actual user plane information is going to be then mentioned here. Plus, if there is any change in your quality of service. Okay, so here, if you can see, it is giving the E node B tunneling ID. So this is the E node B tunneling ID, and this is the IP address of the E node B. So it is informing that okay, if you have to communicate with E node B, and if you see that this is corresponding to the one that we received, we checked earlier. Okay, so this is the modify bearer request, and then based on that, you get a modify bearer response where SGW is going to inform you of the IP address. So this is the S1 SGW IP address is going to be this one. Okay, bearer ID 5. So based on this, the core IP where so Khalid, this question has already been answered. This is not 4 IP address. This is just 4 octets. IP address is this 10.253.71.157. Okay, this is 4 octets. It's not 4 IP addresses. This is 4 components of a single IP address. So modify bearer request and you have your modify bearer response. Okay, so your 4G trace completes here. Your 4G attach. Okay. Detach procedure is not a very significant one. Okay. Rather, what I'd like to add here or discuss here is the voice over LTE signaling. Okay, this is something that since I disabled my voice over LTE, so there was no voice over LTE communication. Now I enabled my voice over LTE, so this is something that that is going to be requested. Okay, so it starts from here. PDN connectivity request. So I am giving that okay IMS initial request, and this is my APN for which I need a PDN connectivity request. Then your authentication and all that, this is not covered here. There's the same authentication and relocation of the information is going to happen. Then you send a create session request. Okay. And this is GMT create session request. And here it is going to follow the same information. MG, MSISD, and IMEI, the quality of service, the location information, and your the tunneling ID and the GTPC IP addresses, the GTPU IP addresses. This is my APN. Okay. And basically, I think Yasser asked this question that, okay, why do we need to have a separate PDN connectivity request? So the question, the answer to that question is that, and we can see here as well, is that for every APN, there is a separate session is created. For example, for my normal internet APN, one PDN connectivity, one PDN session request will be created. If I have a different APN, then I will initiate a PDN connectivity. So when I send an attach request, the PDN, the first PDN connectivity request or session request is by default. So I have a default bearer. Then if I need to use another APN, again, I will initiate a PDN, and this is again going to be a default bearer. So every APN will have its own default bearer. If I have 3 different APNs for these 3 different services, I will have 3 default bearers separately. The dedicated bearer basically has this is for the same APN. Your APN does not change. Your IP address does not change. Just your quality of service information changes. So if over the IMS APN, my signaling is established, but when I initiate a call, then I will need a dedicated bearer. Then my APN will remain the same, my IP will remain the same, but I will get a request from PCRF and PGW that I need to have a dedicated bearer activated. And I have the trace for that as well. So we're going to look into that as well. Okay, so you have your AMBR information, you have your MBR and GBR, as you see is 0 because this is a default bearer. And your QCI is going to be QCI is going to see, and here you can see the bearer ID is 6. The first one was in the first one the bearer ID was 5. So the ID start from 5. So 5, 6, 7, 8, 9. This is what is configurable. So I have a separate bearer for my Jazz APN, and I have a separate bearer for my IMS APN. So my IMS communication is going to be, and obviously I will have a separate IP as well. Okay, so this is my create session request for okay. So some question. Okay, if user have 2 APN, then which APN bearer will be established and attached by both will be established? No, only one bearer will be established, and obviously handset recognizes that the IMS one, because for your browsing you will always have a single APN, or you can have multiple APN as well. But when you configure in your handset, you configure that what is your primary APN. Okay, if you open up your handset configuration, it will only allow you to configure to it will allow you to configure multiple APNs, but in but in the field of browsing, it will only allow you to select one APN. It will allow you to select which APN you want to use. For example, in the old days in Jazz, when I was working in Jazz, We had multiple. We had Jazz Connect. We had Jazz WAP for WAP. We had Jazz Connect for normal internet. Then we had MMS APN as well for MMS. Okay. So in my handset, I used to have three fields available for internet, for WAP, for MMS. So for MMS, I used to select the MMS APN. For WAP, I used to select the WAP APN. For internet, select the internet APN. So when I need to initiate a request, I used to select which APN needs to be used for that. If it's connect APN, then it's going to be connected. In 4G, once again, in 4G, the automatically it will bring the APN which is selected in your internet connectivity settings. Okay. If you open up your handset, you're going to see that which APN for internet is being used. So the APN which you have selected for internet services is going to be carried in attached. Okay. If by mistake you have selected IMS, then you're going to see that the user is going to complain that okay, I'm not able to I'm not able to use data services. When you're going to troubleshoot, you're going to say that his default bearer is being created with just IMS APN, and IMS does not allow internet browsing because IMS will always be routed from PGW towards IMS. It will not be routed from PGW towards your ISP, so you cannot perform any browsing. So answering your question briefly, in attach request, just one bearer is created. It is a default bearer and it is created based on the APN which your handset is selected for internet. Okay. Abu Bakr is asking default bearer is during attach and dedicate during any call. Yes, exactly. Default bearer is during attach. It always stays with you until unless you get detached. Dedicated bearer is when you are requesting for a service which cannot be handled by your default bearer. This is something that I explained very crudely, that you need to travel from say, Pakistan to Dubai, or Pakistan from Islamabad to Lahore, and then from Islamabad to Dubai. From Islamabad to Lahore, you have option available. You can go by car, you can go by train. But if you're going from Islamabad, let's say from Islamabad to like Washington, you cannot use car. You are going to use by air. So this is so a dedicated bearer, a dedicated transport service is going to be your air airplanes service. Okay, your default is car, but since car cannot support that, so your transportation service is going to be upgraded, and that is going to be your dedicated service. So this is something that user may not initially usually just ask, okay, I want to travel. Then your embassy and your transport service is going to tell you that okay, you need to subscribe to your airplane services in order to do that. So just a crude example, but just a simple example to understand that how it works. Okay, so EPS bearer ID is 6 here. What happens in the PGW, we will see in the presses afterwards. Okay, or I think we can cover it here as well. You will get a better understanding. Okay, so let's just open a user trace. Okay, this is a user trace. Create PDP. We're not looking after create PDP. Since we're discussing the create session, so let's just come down to create session request. To where did we have create session request? Okay. Credit control, create session. Okay. So we're starting off from here. Okay. So once you get a create session request, so this is just in the other direction. The source is your MME, destination is your SDW. So it's just similar to what we were seeing here. Okay. So it's just a replica of that. Create session request. Okay. MZ, MSISDN, IMEI, and then your look tracking area information, your cell ID information, then your MNC, then your RAT, which RAT is being used. Then you'll see the same, the S11 MME GTPC IP address. Then you're going to the PGW S5 control plane IP address. Then the access point name, this access point name for APN, which I'm requesting the service. Then which sort of IP address I'm asking for an IPv4 address. And if there is a static IP, it will be mentioned here. No static IP, so no, nothing. Is there any maximum APN restriction? No, there is no restriction of APN. Here, the AMBR, the aggregate maximum bit rate, for default bearer, it is going to be AMBR. For dedicated bearer, we're going to say it afterward. So this is the AMBR information. PC information is not okay. In PCN information, you can see the DNS. If user is asking for a specific DNS, so its DNS information is going to be carried here, but there is no specific DNS information requested here, so it's not mentioned here. Okay, and then it's going to the DNS is requested, and the quality of service information is mentioned here. MBR and GBR is 0 because this is a default bearer, and here you see the APS bearer ID is 5 because this is my internet APN, and then the time zone information. Okay. So after this, what is going to happen? What is going to happen is that you are going to communicate with PCRF and with OCS. So first we are going to have a look at the messaging with PCRF. So it's a credit control request with your PCRF. Again, it's a diameter message. So source address, the PGW address, and this is the destination address. You will get to see so many default ABP information. The one that is required by us is it's an initial request. So which sort of request is this? This is an initial request. Okay. Credit control. So there are 3 types of CCR messages. Credit control initial, update, and terminating. So this is an initial request. This is a new PDP is being a new session being created. So it's an initial request, the first request. CC request number is 0. It increments if there are multiple requests. Okay. The AMBR information. Here you're informing the PCI that okay, I need this AMBR information. This session, the bearer that needs to be created has to be this. This is the default EPS bearer quality of service information. The QCI that I requested is QCI 9. So you need to assign me a policy that has QC that can support QCI 9. The allocation and retention priority information again based on this, and then I'm going to give my APN. This is my APN for which because in PCR you can have APN based policies as well. So many things that you can do in PCRFs. You need to inform each and everything to the PCRF to ensure the PCRF provides you the correct IP address. Okay, so this is your charging gateway IP address, and uh, this is the IP address of yours. I mean, this is not your charging gateway. This is your PGW IP address. This is your charging gateway IP address. Okay. User equipment information, the IMEI SV, the IMEI number. Then what sort of charging do you need? It's an online. Okay. So online is supported and offline is supported. So both are supported by the PGW. So it's just informing it that online is supported and offline is supported as well. Okay. And then you are giving the SGS and IP address because in PCRF again you have the option of creating a policy based on different SGS and IP addresses. Okay. And then you're giving your gateway IP address. This is your PGW IP address. You're providing the RAT type. Again, your policy can be based on RAT. For 2G, 3G, a different policy. For 4G, you can have a different policy. Network requested supported. Okay. This is your MNC MCC. User location information. This is again required because you have your location related policies as well. You must have heard of location based policies. Okay, so I mean, in a specific location, I need to give a higher throughput because I'm launching my 4G service over there. But if user comes out of that location, his throughput is going to be degraded. So PCRF is, I mean, the majority usage of PCRF is usually for location-based policies. So you must inform PCRF about the location information as well. All this information you can use for troubleshooting as well. I mean, if you're getting an issue that okay, user is not getting the required throughput, then you need to check its location information that okay, which location information is being sent by the user, whether the user is actually in that location that he's asking, and you can check it in the location, or if a user which RAT type user is using. So all this troubleshooting is done based on these EVP information, the AVP information. Okay. This is the IMSI. So whether it's the correct number that the user is using, MSISDN. Then we come down and we see that the IP can trigger EPS5. Okay, so all the basically all the required information that the PCRF needs to make a decision has been shared in this credit control request. Okay, and based on this, PCRF is going to share the policy that is most suitable. Okay, so if you see a response from the PCRF, okay, so it's just going to be the initial information, the source address is PCRF, destination is the PGW IP address. Okay, some AVP information which is by default being used. Okay, this is the PCRF name. So this is the result code. This is very significant. Diameter, you should have diameter success in order to see that whether if it's not success, then obviously you won't be getting information and your service is going to fail. So CC request was 0, so its response in response also is 0. It was initial, so it's credit control answer I, CCAI. Passing down, we are going to see. So this is the charging rule. This is the name of the policy that the PCRF has selected for this user. Okay. So this policy is being assigned, and this policy will obviously be created on GGSN as well because GGSN has to enforce it. So this policy is going to have its own quota information, is going to have its own QCI information, its own throughput information, how much throughput to assign. This will have how much to charge, and this is even associated with different rating groups and different filter information, which service to allow, which not to allow. So main thing is this. Okay, this is the event trigger because I changed my RAT. So why this is being sent? It is based on RAT change. Previously I was on 3G, then I moved to 4G. Okay, so APN, AMBR. So based on this policy, the AMBR information is this. So up for downlink and for uplink. QCI is going to be 9, which was requested. Your ARP information. So ARP information will discuss. So main thing is that you're getting their specific policy. Then if you have AAA server configured as well, so you're going to send an accounting request message to your AAA server as well. Okay, accounting request start. Okay, and I'm giving my IP address. This is the IP address that has been assigned to me. This is my MSID and this is my APN. Okay, and my IMSI, my charging ID. Okay, and the negotiated quality service is not required. The SGSN IP address, the GGSN IP address, the MNC, MCC, and SAPI information. Okay, so which RAT type I'm using. Okay, my cell ID. All this information is being sent to the AAA. Okay, AAA server accounting start. Then you'll have an accounting response as well. So we'll just see this first, and then we'll go to the OCS messaging. So it is just accounting response. It is respond. Usually, accounting start and accounting response is just a response that okay, I've received your accounting request, and then I will start with the accounting information. There is no successful or unsuccessful request. So next we come to the OCS. Okay, and this what do we have here? Give me a minute. I think it's been 1 hour. Let's just conclude this and then we can take a short break. Okay. So credit control request to your OCS. Okay. So diameter credit control request, AVP information. Okay. The origin host, your which EPC, which RAM. All this is pretty different. This is an initial request. This is important. This is CCRI, the first request. Okay. And my your MSIGN information previously would be my IMSI information as well. Okay, so I'm giving my MZ as well. I'm providing the multiple service are supported. The MSCC is supported. Then I'm giving my IMEI information as well. Okay, the charging ID as well. So all these are basically the information that I have available, and I am sharing it with OCS so that OCS can have a better idea which policy and which rating group and which service do I need to assign. QCI 9. Uh, I think there are a lot of messages here. We can take a short break, okay? And we can just come back in 10 minutes, okay? We'll resume at 9 o'clock and then we will look into this a little bit more deeply, okay? So let's take a short break. Okay, welcome back. Let's just start where we left. Okay, so I was just looking for any rating group related messages. I couldn't find. So let's just concentrate on this. Okay. So your communication with your OCS. Okay. So it was an initial request. The CC request was 0. Then you had your timestamp is not required. The MSIGN information. You'll have your MZ information. You have your MSCC whether it's supported or not. The IMEI information. Okay, charging ID is specific to a session. You create a session, so one session has one charging ID. Okay, once you terminate the session and initiate a new session, the charging ID is going to change. So this is how we identify the CDRs of a particular session of a user. I mean, multiple CDRs are created. There is a limit, like one CDR can be maximum of 1 MB sign, uh, 1 MB size, or it can be for 5 minutes. So every 5 minutes or if 1 MB or it has been consumed, a new CDR is created. So all these CDRs are linked by the charging ID. Okay, so one session has one charging ID. So it's the IP address is IPv4. This is your PDP address. Okay, this is the IP address of the user has been assigned. Then the QCI value is 9. Okay, then you have your ARP information. What ARP information? Okay, and your APN aggregate max bitrate, uplink and downlink. Okay, SGSN IP address, the GGSN IP address. Then you're going to look at the CG, the charging gateway IP address. All this information, the basic information, MNC, MCC, GGSN, MNC, MCC. This is MZ, MNC, MCC. So all these are basically requirement of your diameter protocol which you have configured. You're providing your APN information. You are providing the charging ID characteristics if there are any specific. Then your SGSN, MNC, MCC, your time zone. You're providing your location information because on OCS again, they can be location based. Policy is RAD type, on which RAD type user is connected. The charging ID, again, it's part of this AVP as well. Okay. And the charging rule name that is being used by default is the up default. So this is the charging rule name which is being used for your routine browsing. This is the case where I activated a new session. I did a request for a specific service. Okay, so my background application, all that. So those will be catered by your up underscore default, the basic charge rule name, which has been provided by PCRF. As we checked that PCRF provided this, so this same has been provided with the OCR that you need to charge me according to this. Okay, and then you have the response from OCS is going to be your create session is credit control answer. Okay, so in credit control answer, the main thing is whether the request is accepted or not. Yes, request is accepted, and then you are going to see your different PC number, and this is the initial request. Okay, so this is and the name of the specific OCC which is going to serve this. MSISDN request. Okay, then if you have an understanding of CUPS architecture, so this messaging is for your CUPS architecture where your control plane is going to communicate with your user plane. When we will discuss the CUPS architecture, then we are going to look at into this two messages. Right now, it isn't required. Okay. So, and then you have your create session response, which we already saw in the other one as well, in the attach request as well. Okay. So you create session response, you'll get to get your IP address. Main thing is your IP address and your interface request is accepted, your SGWU IP address, the PGWU IP address, and the user assigned IP address as well. Okay. So we'll come back to what we were discussing. So we were discussing this the PDN connectivity request for IMS. Okay. So once you get that, now what happens is that since I did this, so now it will ask user for activating a default EPS bearer. Okay. So this is so this is now being sent by request was sent by uh, user equipment to MME. So based on that, we'll ask it to activate a default bearer. Okay. So this default bearer is going to be requested to be created. I'm providing the APN information is being provided, the IP address. So if you see, the IP address has been assigned. So this IP address is what is assigned against this IMS APN. Okay, and the quality of service information, the AMBR information, and then it is being asked to create a bearer. So based on that, you're going to have some uplink NAS transport. Then you have ERAB setup request. This is being sent to your user equipment. Then you're also requesting the eNode B to establish a RAB request for this specific IMS quality of service. Okay. So here you are going to send an ERAB setup request. Again, the same information you are providing the S1 application ID for MME, the eNode B application ID, and the priority level, what is going to be the ERAB ID. Okay, so here you can see its priority level is highest. Okay, and shall not trigger preemption. Okay, so preemption capability is that it cannot be preempted, and pre-vulnerable capability is that preemptible. It can preempt other bearers, but it itself cannot be preempted. And then this is the IP address of your SGWU, which is going to be used, and the GTP tunneling ID. So based on that, your ERAB is going to be established, and your eNode B is going to respond back with that. Okay, so it's successful outcome. The RAB IDs, the transport layer IP. This is the IP address of your eNode B. Okay, and then based on this request, you will have a response as well. Okay, so it says that okay, activate bearer context has been accepted. Okay, that I am willing to establish another default bearer. So after this, there will be two default bearers on user. And then you have the routine modify bearer request and response. I'm not going to go into this again because this is we covered that this is basically updating the SGW with the IP address of eNode B, and then it is going to acknowledge that. Okay, so this is your PDN connectivity request for voice over LTE. And just one more thing that we need to check is your voice over LTE call. Okay, so now we will get to see the dedicated bearer request as well. Okay, so this PDN connectivity, I believe, was for IMS. Okay, so this is a combined. This is the PDN, the IMS control plane and the IMS user plane. So based on this, it is going to be the bearer ID assigned is going to be session request and activate bearer, so bearer response. Okay, and then here you see is that there is a dedicated bearer request. Okay, this one was default bearer request. This is a dedicated bearer request. So once you requested, a request was made that okay, a call needs to be established. I initiated a call over here. Okay, So a create bearer request was sent. And this create bearer request was basically for specifically requesting for IMS. Yes, this is for IMS. Uh, so I'm basically initiating a voice call over IMS. So I initiated my signaling for IMS was completed here. Then I created a request, a voice call request. Okay. So when I created a voice call request, I got a create bearer request. And this create bearer request is basically to create a bearer for IMS voice call. So bearer ID is is not provided. This is the IP information. So the main thing which we need to look is this one, the activate dedicated bearer request. Okay, so based on that, the PCRF is going to inform you that you need to activate. So here the QCI is one. Okay, a bearer needs to be established with QCI one, and now you can see that you have the MBR and the GBR information as well. Previously it was all zero. Now it has information that okay, a bearer. What's the IMS? IMS is IP media, IP multimedia subsystem. It is used for voice over LTE call. Okay. Voice over LTE call. If you have IMS, you have integration between GGSN with PGW and IMS. So you do not need to fall back to 2G and 3G for calls. You can directly initiate a call in the while staying in 4G. So that is done by a dedicated bearer. How IMS works, you can skip that part. We can cover it afterwards. The main thing of showing you here is the difference between a default bearer and a dedicated bearer. Okay. So how a dedicated bearer, the main thing to understand is that it is always network initiated, not user initiated. Okay. So it is network initiated request. And here you can see that the MBR and the GBR has been assigned. Okay. And this is the quality of service which needs to be ensured. So here you can see that you have the MBR mentioned here, you have the GBR here. So your user equipment needs to establish a bearer. It should be capable enough to establish a bearer, which can ensure this MBR and GBR as well. Okay. So this is the response by the MSISDN or the user equipment is that it has accepted, it is ready to accept to create this bearer. And then it is going to send, and then MME is going to send a bearer response to your SGW. Okay, this thing that I failed to mention is that this create bearer is SGW to MME. Okay, SGW because PCRF informed SGW and SGW informed MME that you need to inform that you need to create a new bearer. And based on this, you sent an activate bearer to MME. So here, since user equipment is accepting to create a dedicated bearer, so now it will send a response to SGW that okay, a bearer can be established. GTPC response. Okay, local IP, peer IP address is not required. Here it is going to inform that which is the EPS bearer. So here now the EPS bearer ID is 7. So we started with EPS bearer ID 5 for internet, EPS bearer ID 6 for signaling of IMS, and then EPS bearer 7 ID 7 is now being used for IMS call. So eNode B IP address is being provided, so direct communicated with eNode B and the SGW user interface, the SGWU IP address they provided here. Then there's no adjustment for time. Then the user location information, the tracking area ID, and the ECI information. Okay. So the main thing is this bearer ID. The request has been accepted, and your bearer ID is going to be 7 EPS bearer ID is going to be here used. Then your update bearer request. Here it is going to inform the MME that this is the IP address. Okay, this IP address is going to be used, and then it is going to inform the IP address of your U of PGW as well. Okay, bearer level quality of service information. This is already discussed, so there is no update in this. Okay, and then modify EPS bearer request. Going to inform the user equipment that you need to modify the EPS error based on this update error request. So your modify bearer request is going to be sent. Okay, where you're informing that okay, if you see earlier the MBR and GBR assigned was 44. Since the negotiated one is now new EPS quality service bearer is now 32. So since that is being changed, this is what is being informed by your SGW. So this is something that is now being being informed to the user equipment as well. Okay, to downgrade the bearer information from 44 to 32. Right. So after this, your call is done. And once your call is completed, so you will initiate a delete your because your dedicated bearer is established only for a specific service. When your service is completed, your bearer gets deleted. Okay, so it will send a delete bearer request. Then you have a response of that. Deactivate EPS bearer request. Its response, and then your bearer is all is responded. So your default bearer will keep will be kept till you're detached, but uh, dedicated bearer is going to be deactivated once you get detached. I think in the second one, maybe there is. I think it's going to have the same messaging. Okay, this is basically including the internal messages. I don't think this will have any. Let's just check. Yeah, it's the same messages. So deactivate dedicated bearer. Fine, fine. So this one is fine. Right. If you check a generic GX and Jiva interfaces, so what you're going to see here is usually it's a credit control request and credit control answer. Okay. Uh, Usually since I captured this on an interface specific interface, what I was trying to find, I will see some more traces where I get to see where I get to show you the CCRT messages. I was not able to find any CCRT messages. I wanted to show you how the quota is assigned and how, but that we can cover when we cover the diameter protocol. Till that time, I'll be able to simulate a scenario where I get a quota. Okay, I think we have an update request message. We can just cover it overall here, and in depth, we're going to cover it when we discuss the diameter protocol. So this is an update request. User MZ multiple service requested. Okay. So here you see when you create a rule in your MSCC, every rule has a service identifier and has a rating group. And it is based on this service identifier and rating group that the OCS charges the subscriber. Okay. So when you're sending a request, then you're sending, okay, this service and this rating group, I'm sending an update request. An update request is basically to ask for more quota. So all the user specific information, this is QCI 7. For QCI 7, it is requesting for more quota, and all the basic information is being sent. The main thing that you need to check is which rating group is being sent. Coming down the user location information, the charging ID information, the serving node, so this is the charging rule name, and that is the quota information. Let's see if I can get a response of this specific update request as well. So here you're going to see whether it's an update request or not. So first of all, it's a diameter success, and let me check if it's an update request. So it's a CC request number 131. So it's update request 2. Okay, so this is a response of that. And here you're going to set that, okay, the diameter control code is 2001. Okay. And here you can see the total octets that has been assigned the granted service unit for this specific rating group that was requested. So I am assigning you some more octets which a user can use. So granted service unit for this is this. And this is for rating group number 14. And service identifier 11. Okay. Then again, for another service, the diameter credit limit is reached. Okay. So for routing for RG11, this one was for RG14. So for RG14, the quota is available. So it has assigned this specific octets. But however, for RG11, your credit limit has reached. Your quota has expired, so it cannot assign you. And the service identifier is 11. Okay. So each and every service that you're using, you will have a specific rating group assigned to it. Again, diameter success is for success. So total octets in granted service unit is this, and this is for rating group 17. Okay, so you can have quota update for multiple using multiple services. Facebook is going to have a different rating group. YouTube will have a different rating group. Google will have a different one. So for every service, when you get an update request, you get an updated quota. Again, it's diameter success, the content. So this is rating group 15. Okay, and service network. So currently, this service being used by the user were 4 different rating groups. One was expired. Once quota 1 is expired. For example, the package is expired for a specific service. For the rest of this has been updated. Right, and in PCRF, usually similar communication happens, but the thing that you need to check in PCRF is that there is a reauthorization request. When your quota gets expired on PCRF, then PCRF will not wait for the service to be end. It is going to send a reauthorization request, and it is going to ask the GGSN or PGW to assign some new policy. For example, in PCRF, we define a default policy as well. If all your bundles are exhausted, you get a default policy. So PCRF is going to send a default policy in the reauthorization request. So let me just check the MSCC here if the request is just for rating group 11 and request yes. In this one, this just for rating group 11. Okay. So in GX interface, you will see credit CCR and CCA, but you will also get the reauthorization request as well. And this will be PCRF initiated. And here the PCRF is going to send a new policy that, okay, this is the new policy which you need to send to the super. This can be based on if your quota gets exhausted, or it can be based on if you change, if you have defined, I mean, I have a PDPS session that is created, and then I update my policy. Okay, so if I update the policy, I increase the quota, I assign a new policy. So that is then done by reauthorization request. Okay, so event trigger is revalidation timeout, then the AMBR information is given, and then your reauthorization basically gives you the updated policy that is being that the user is that the PCEF, the PGW working as an enforcement function is then going to enforce. Okay, so when you take a trace on GX, you will have the CCR CCA as well as the reauthorization request and authorization response messages. No, on GY there is no reauthorization. GY it's diameter request and response. On GY interface, I don't know. There is no reauthorization. It is on with only from because your quota, your policies, and all that information is being managed and being enforced, is being ruled by the PCRF and enforced by PCEF. OCS is just responsible for providing the information. Okay, any information that it has, it is going to just provide information. So if you pass through all the GY requests, I don't think there's going to be a reauthorization request. Change the validity timer. If I change a validity timer of a specific policy, of a specific rule, reauthorization request, this I need to check. Okay, this I will just check and I will confirm back to you that if a user is using, even if a user is not is live and he is and during real time information, I change some information so whether a RAR is going to be sent or not. This is something that I will confirm back to you. Okay, I just note it down and I will confirm it back to you. Okay. Yes, for GX, yes. For GX, it will be sent. For GY, I mean, for a G on the GY interface, if your answer is regarding to GX, yes. For GX, if there is any change in the policy in the PCRF, and yes, if anything that is changed, that is going to be a validity timer is usually not for the PCRF truth. Validity timer is usually for the communication with GY, your charging rules. Okay, PCRF is going to send a reauthorization request when there is a change in the policy at the PCRF end. Okay, you change the subscription, you change the para, or there is a policy that is expired. If your question is that will if you change the validity timer or something like that on the of a rule, will there be any change, any RAR on GY? This is something that I will check. Okay. Okay, so we looked into GX, we looked into GY interface. Let's just get back to our presentation. Uh, these are because these are not very detailed. So the main message that is left to be discussed is your tracking area update. Okay, these messages, the S1 connection release procedure, this I will share with you. Okay, and you can check the information, but this isn't something that usually involves in the basic call flows. So we can take a look at these in the next session. I think 2 hours is enough for today. So the basic thing, the basic intention in today's session was to get an idea of how the attach procedure and your PDP session, and I added the PGSN and the PGW traces here as well in order to ensure that we have a better understanding of that. The rest of the secondary procedures we can cover in the next training session along with the tracking, because tracking area update procedure is a very significant procedure. So we need to have a better understanding on that. Detach, S1 connection release, service request procedure. These procedures usually do not require any troubleshooting. I mean, if your detailed success rate get degraded, no one is going to ask you that why degraded. Or if your XS1 connection release success rate gets degraded, no one is going to ask you to troubleshoot that. Troubleshooting is usually for a attached procedure, your PDN connectivity, your tracking area update, or your handover, or maybe your security, even your security procedures, security related KPIs are not basically, this has a direct impact on your attack procedure. So if you find something in your attack procedure degradation is found that is because of security, then we take a deep look into the security procedure. Other than that, we don't have any concern with any of these procedures. So that is why I'm calling these to be very insignificant or not very. They can be called secondary uh, procedures. These are not the primary procedures that we need to be concentrating on. Okay, so I think it's enough for today. We will continue on next Saturday, hopefully. And till then, you guys, I will share these training slides with you. A video, again, this is something that I need to check whether I can share the video. The training side, I'll just customize them, and the traces I will convert them into text, and then I can share it with you. Specifically in this format, you won't be able to open it, and Varsha, you won't be able to understand. So I will just convert these traces into text files, and then I will then share it with you in the group, and then you can open up the traces. And what you need to do is that you open up the call flow. Any document, you have a headaches document, you have 3 GB document, you open the call flow, and then you compare it with traces to have a better understanding that what information that you need to carry or what information you need to investigate during any troubleshooting or during understanding of a call flow. Okay, so this is something that you need to do on your own. So please try to replicate this. Try to get all information from 3GPP. I'm just covering the basics, but what I expect from you is to search from some documentation like 3GPP is a good documentation. So you can open that document. It will give you detail, and then you have the traces, so you can have a better understanding on the call flow and how call flows works. Okay. And if you have any concern with that, you can always approach me. You can ask me any question. You can give me a reference of that, and we can then discuss it accordingly. Okay. So till next week, thank you very much for your time. Thanks a lot, and see you. Take care.